I've spent the past 30 days alongside my day job improving my algorithmic trading framework, and I made some really great progress. I fixed some crucial bugs, improved performance significantly, like reducing chart loading times by over 10x, and added a number of features that makes the entire system much more usable. In this video, I'll walk you through what changed and show you the state of the current framework. So I ended the last episode with tick-based chart updates, but two main issues showed up here. The first is that current candles had missing data after a reload, which only was fixed after the next 1 minute candle closes. And the second problem was that the chart felt a bit laggy, even though with only price updates. Adding indicator updates on top of this would likely make it unusable. So these became the first things I had to fix. And the root cause was pretty much how I calculated the candle. I did on-the-fly calculation in the front end based on the tick data, which probably was just not the right approach. Instead, I'm now using candle updates. And for this, I had to do some refactoring in multiple services, like the broker service, which publishes the candles, the ingestion service, which already used the candle updates, but only the on-closed candles, so I had to do some changes here. And of course the web server and the front end, which consumes the candles. The second issue was pretty much that I had a bug in my front end that caused a full chart reloading whenever the current candle updated. So let's jump to the charting software. You can see when I refresh the page, the chart loads almost instantly, which is a major difference to the previous versions, where chart loading took about 3 seconds, which is not too bad, but nowhere near the current performance. How I achieved this performance I will show you later in the video. And what you can also see is that when I refresh the page, you can see that the current candle is also updated with the open, high, low and close of the current candle, and not only the current tick. And I can of course also switch the time frames, and these higher time frames are loading even faster than the 1 minute candles. And I can, of course, still change the symbols to all the symbols that are in my database. And when I zoom out, I can, of course, still load more candles whenever they are needed. And most importantly, when the chart is loaded with more candles, it does not start to lag anymore. Next feature is pretty hard to show you, and you won't really notice that it is implemented, but you have noticed that it was missing in the past. And this is the token lifecycle of the cTrader API. Before I had the problem that the access token is expiring after 30 days. That means I had to go through a manual process to generate a new token, update it in the config and rebuild the software. This is of course not scalable at all and nowhere near a production environment. But cTrader not only provides the access token, it also provides a refresh token. So as a solution, I'm now using the refresh token to generate a new access token whenever this is near to expire. So with this, I don't have any manual intervention anymore and have to regenerate tokens after 30 days. The next feature are shared libraries that I've introduced to the framework. Now it really pays off that I'm using Python for all of my backend services, because the first library that I've implemented was the database accessor client, which improves the development experience and code quality by a lot. Before, whenever a service needed to access the database, it had to generate a client and define the host, the port, the parameters and so on, all by itself. So I had in all the services duplicated logic everywhere. And now with the database accessor client, getting data is as simple as calling a function. Let me show you this quickly in a code example. Here for the indicator API, for example, I just need to create a database accessor client and then call this client with a function getCandles. And there define the symbol, time frame, exchange, and start and end, and the limit. for the data which I want to fetch, and then get the data returned as a data frame. Talking about indicators, this is the fourth feature that I have implemented. Let's go back to the architecture. Here you can see I have also implemented an indicator engine to calculate indicators for the indicator API, for example, or the backtester, and also in the future for trading bots. And you might also be missing the indicator streaming service, which I decided to now not put into a separate service, but instead put into the existing indicator API. I just felt like this is not enough functionality to create a new service, so I put it into the existing indicator API. And here I have now two main routes, one for historical data and another for start indicator streams, which are then published to Redis streams and can then be read by all the services, like for example the web server, which then redirects us to the front end. So let's have a look at the indicators in the charting software. You can still add the indicators through this button, and let me add some indicators here. And you can see the indicators are loading almost instantly. And they are also updating live for the current candle. You can of course still zoom out to load more data. And loading the chart is still pretty fast. Most importantly, it doesn't lag anymore. You can of course also change the settings of the indicators, and the indicator is then updating accordingly. Now let me tell you how I achieved this performance. Already since the beginning I was using TimescaleDB, but I was using it pretty much like a general PostgreSQL database. So now I've done some major improvements to actually use the performance of TimescaleDB. The first main improvement was using hypertables, which is time-based partitioning. So data is chunked by days, and queries only scan the chunks that are actually relevant, which then avoids full table scans. And the second improvement are continuous aggregations. Before I had for higher time frames always on-the-fly aggregations. So whenever the data was requested, I only had the 1 minute data in the database, so I had to calculate the higher time frames based on this 1 minute data. And these are now pre-computed. So therefore the higher time frames are even faster than the 1 minute time frames. So this is now scalable with millions of candles and the major contributor to these insane loading speeds. So we have now fixed some core sharding issues, and we have improved data loading in general, which also impacts the chart loading times, and added fundamental features which improves in general the development of the software. I think with this we have now built a great foundation to focus next on the backtesting. Thanks for watching and see you in the next one.